Greetings! Welcome to the CMP 1001 Introduction to Programming with C++ video series. In this series, we will make an introduction to programming with, as you might guess, C++ language. In this first video, we will look at programming in general and talk about the basics of C++ programming, in particular getting the input from the keyboard, giving out the output to the console, and C++'s core variable types. Well, as you might imagine, this is a computer, or in more particular saying, this is a desktop computer. A computer is a device for counting and computing. It counts and it computes. Alternatively, you can call a computer that is a machine that can process data. There is always an input that you give to the computer. He just processes this input and then he generates an output based on the process that you have defined him to do over the input. One of the main differences between a human and a computer is the fact that a human can reason. So you do not have to tell a human being if you want him or her to do a particular thing every single little tiny steps. Instead, if you want a computer to do something, you have to tell him step by step every single thing. So to perform some task by computers, you need to tell all these necessary steps. These steps can also be called instructions or statements, or if you will, commands to the computer for it to perform the task. So the list of such instructions is called a program for that particular task. So we can say like the purpose of programming is to find a sequence of instructions that will automate performing a specific task or solving a given problem. Basically that. If you follow the comparison of making a person do something versus a computer doing something, you have to tell that human being in a human language that, okay, can you do this? I want this garden to be maintained. I want this door to be closed. Things like that. So you need to use a regular human language. In order to communicate with the computer, you need to say these instructions in a programming language. So the language word is a very important thing here, and it is like a language, like a human language, like an Italian, Turkish, English, Russian, Japanese, whatever. So the C's, C++, Javas, C Sharps, Pythons, these things are something like of a language. It has certain rules, it has a grammar, it has some literature around that, and so on and so forth. Very roughly, we can divide the programming languages into two categories, the machine language and high-level programming languages, such as the ones that I have already mentioned. Among these two, the machine language can be considered as the actual native tongue of the computer. So this is, if you again follow the comparison between a human and a computer, this is like the native tongue. So this is basically like the 001s, 11110, and like each instruction is like a binary string. Obviously, nowadays, nobody writes a program using this machine language. That would be extremely time-consuming and very, very prone to errors. And after a while, most likely these programmers will either go nuts, lose their minds, or they will just write down programs that takes a lot of time to do and debugging extremely hard, to say the least. The second group of languages, on the other hand, are mainly human-readable languages. So the thing here is, if you try to read a C code or a Python code, if you know the English language, you will most likely understand roughly what is going on here. Because a lot of this terminology regarding these programming languages are based on some English words like if, while, do, things like that. Each one of these high-level languages have their own standards and predefined instructions. So you have to know them, you have to understand how to use them, what they are useful for, what they are not suitable for. And each of these languages have libraries that are coded by other people, commonly referred to as application programming interfaces, APIs. There are lots of APIs, each one of them has some specific purposes. It could be video game development, it could be network packet sniffing or packet handling, image processing, machine learning, so on and so forth. So nobody knows all the APIs possible, that would be not very possible, and you just don't have that much time. You just understand, learn the APIs that you will be needing for your specific tasks. That is the key thing there. So it's like you just look at some part of the literature when you really want to focus on that topic. So the codes written in these high-level languages are translated into machine languages so that they can run over an actual computer. And this translation is done by either a compiler or an interpreter, depending on which language we are talking about. You can say like there's an intermediary language between these two groups, the machine language and high-level language. There's the intermediary assembler, but I'm just simplifying things so that I just don't want to go into the details about the assembler language. That is something in the middle, which is partly human readable, partly machine language, if I may. Okay, after this rough idea about programming, let's start talking about C++ language in particular. C++ is a general purpose programming language, and it is a high-level programming language. It is a compiled language, so there is a compiler, there is a C++ compiler, and it has huge performance, efficiency, and flexibility advantages over many different languages. It is generally considered to be very, very efficient and fast. Therefore, it's a very good choice for things like embedded programming. For the last decade or so, C++ is one of the most popular languages in the industry. But don't get me wrong, it is not suitable for every single task. For example, if you want to have a web development, generally nowadays you don't use C++ that much. Instead, you just use JavaScript, I don't know, maybe Python at the backbone, things like that. As the name suggests, C++ language derives a lot of syntax directly from C language. But don't get me wrong, it is not a continuation of C, so it is a language on its own. Though it derives a lot of syntax directly from C. And super roughly speaking, many things that you can do in C, you can directly copy that in C++, and you will see that these things are compatible and these things do work in C++. C++ is an ever-changing language by keeping its roots and general concepts, but adapting to new needs as these needs arise. As of 2020, there are 6 versions of C++, starting with C++ 98, which has been developed in 1998, and to C++ 20, which has been developed I think around February or March of 2020. In this lecture, we'll be mainly using things from C++ 14, so additional concepts in C++ 17 and 20 are not going to be that much important for this video series. I am not going to be using every single little thing in C++ 14 also, but there are going to be some things which have been added after C++ 11. So now we have a rough idea about what programming language is. Next big question is, how can I write programs in C++? Roughly speaking, you can open up whatever word processing tool that you'd like, for example Notepad, WordPad, things like that, and you can just type in commands according to the C++ rules. Then you can just take this little code, little file, and then feed it to a C++ compiler such as GCC, and then voila, you have a program written in C++ language. But nowadays, in the industry, people generally use more specialized tools for developing code. And these tools are generally called Integrated Development Environments, short IDEs. And there are different IDEs around, such as CLion, as you can see here, Visual Studio, Visual Studio Code, and so on and so forth. These generally make life easier when you are coding something. They just help you in many aspects, like showing you simple mistakes, like, okay, I think you are forgetting something, so you can fix it there, do a little bit of a coloring, automated variable name renaming, things like that. CLion is one of the most common used IDE for software development in the C++ language. It is a free software, it's a free IDE if you are using it for academic purposes. And it is extensively used both for professional and personal use. If you like to download CLion, all you have to do is go to this website and then register, and then you can download it for free if you have, as I mentioned, an academic email address, an academic account. But CLion, an IDE, is not enough to compile a program. As I have been explaining, you need an additional program, which is called a C++ compiler. So a super common C++ compiler that people love is the one that you are seeing on the top left, the GCC, the GNU compiler collection. GCC is the standard C++ compilers for Linux and macOS systems. So if you happen to have a Linux or macOS operating system, well, surprise, surprise, you already have the GCC, and all you need to do is just download an IDE and you can just start running your codes. If you happen to have a Windows machine though, you cannot install GCC directly because it's only compatible with Linux and macOS operating systems. You need a Windows port of GCC, and there are two very good candidates, the MinGW and Cygwin. Don't get me wrong, you are not limited to GCC or GCC Windows ports of GCC. There are also other C++ compilers for Windows, such as the Microsoft C++ compiler, which is also a good compiler, but I generally prefer a GCC or Windows ports of GCC, so that would be my personal suggestion. So to compile and run C++ programs in a Windows environment, these two things are my suggestions. And in particular, if you want to install the MinGW, just go to this website, as you can see the link, and it's also a free download and you can use it to install the MinGW. Using CLine, C++ programs are written in classes, which are inside C++ projects. So let's open up a new empty C++ project in CLine and see how we can start typing our C++ codes. So if you do not have any project in your computer, if it is the first time, then you will see something like this, very little box of CLine. You just go here and then say new project, and you just define the path that you want your project to be located, and then write down the name. I don't know, we can say like lecture1_1. Next, we will be selecting which language standard, which C++ standard we'd like to use in this project of ours. By default, C++ 14 is selected, and I'm not gonna change that. I just click the create button, and then you see that the CLine is now doing something so that the project is ready for being compiled and then run. You see at the bottom a little bit of a progress bar, and when the progress bar completely goes away, you are now ready to run the program, to build and run the program actually. So I just go here and press the run from the run menu, and as you can see, a new window appeared, and then he's doing a lot of building and linking stuff, and at the end you see that, okay, this is my program, where the program is located. So what he did is he took my code, he just gave this code to the C++ compiler, the MinGW, and then he just converted into a, let's say, machine language, and it is located in an executable file under this path called lecture1_1.exe. This is an executable file, and it is not noted with this file extension because I'm using a Windows machine. If you are using a Linux or a macOS machine, you will see a little bit of a different path and a little bit of a different file extension, or you may not be able to see file extension at all. But Windows, you always need to have an extension. It is either .com or .exe, most commonly .exe. Anyway, so he tells me, this part tells me that I have compiled your program, and then I have built an executable file, and I run the executable file. The output of this executable file is hello, blank, world, ! And go to the next line. At the end, process finished with exit code 0. This means the process has been finished with no errors. So this is the thing that we'd like to see in general. If you see any other numbers, most likely you do have an error, and you have to somehow find the reason and then fix it. We type the commands into .cpp files. As you might imagine, .cpp stands for C++. And commands are named statements in C++. If you remember the instructions, the commands that I have mentioned, they are named statements in C++ context. In most of the cases, you write down the statement, and at the end of the statement, you put a semicolon to represent that the statement is finished. There are exceptions. There are very important exceptions like the if clause, the while clause, the for clause, and so on and so forth. But unless noted down, you need to put a semicolon at the end of each statement. Technically, you can put as many statements in a single line. But generally, putting more than one statement per line is considered to be a heresy in computer programming. It's a very terrible choice, and people really doesn't like it because it really makes reading code, even if it is your own code, very difficult. So the general practice is one line is one statement. So each statement should be in its own line. If you are making a mistake while writing a statement, generally CLine will warn you with an error icon near the erroneous code line. It could be as simple as you have forgotten the semicolon, or it could be some other things, more sophisticated syntax errors and so on and so forth. Okay, we mentioned in the beginning that all programs start with an input. Well, many programs start with an input and then they result in an output. So C++ is a general programming language. Therefore, we get the input from any input source that we want. It could be the keyboard, it could be a mouse, touch screen, a scanner, a file, an internet, whatever you can think of. Similarly, we give the output on any output source that we want. It could be the monitor or the console if you want to say it, a printer, again a file, internet, and any other thing. In this video series, we'll be mainly focusing on the keyboard as the input source and the console as the output source. In the last couple of videos, we will also be using files both as the input and the output source. Okay, let's start by learning how to give an output to the console. For this purpose, we have the std::: cout function to write something to the console. The syntax is, as you can see, super simple. std::: cout, all with lowercase letters, and then you follow it to the two arrows to the left, and then within double quotation marks, you just write down whatever you want to see on the screen. And as I have mentioned, at the end of the statement, you put a semicolon. If you want to go to the next line after writing down whatever you want to do, then you can just, as you can see, add it with an std::: and L. But you have to put these two arrows to the left in between the greetings and then the std::: and L. Okay, so let's write a program that writes hello blank CMP blank 1001 exclamation mark on the console. Here's my code, auto-generated code. The auto-generated code in CLine is a code that's composed of a single line which just says std quote hello comma blank world exclamation mark. So all I have to do is change this part to hello CMP 1001 exclamation mark. Then I just go and run my code. And voila, hello comma blank CMP blank 1001 exclamation mark. So that is perfectly fine now. We successfully gave an output to the console. You might be noticing some things like the int main here and then return 0 and closing curly brackets, things like that. For the time being, we'll be putting our codes in between the int main and the return 0. When we look at the functions, we will understand what these things mean, and when at that time we will get out of this int main and returned part. But for the time being, we'll be writing our codes between this int main and this return 0 lines. When we look at the other way around, getting input from the keyboard, we also have another thing called std::cin. However, getting an input from the keyboard is a little bit trickier than writing something to the console. The thing is, the main difference here is we need to define where to put the inputs that we get from the keyboard. Then we'll be using the std::cin function to read the input. So what do I mean by define where to put the inputs we get from the keyboard? So let's imagine that you are telling me a number and then I have to somehow keep that number in my memory. But let's assume again that I'm a super forgetful person. So if I don't write this number down somewhere, I will immediately forget it. And if you ask me again what was the number I have told you, I will have no idea what was the value of that number. So since I know that I'm a terrible forgetful person, I have a little bit of a system. So whenever you tell me a number, I just take a piece of paper and then write that number with a name saying that this is where Ahmet told me this number. So I declare a name for that piece of paper. So every paper has a separate name. And every one of these papers is a location where I put the input where I get from another person. Following the same concept, computers have what I would be calling a variables. Variables are basically some memory spaces, a part of your computer's memory. The most basic variable type is called integer, which can hold an, surprise surprise, integer value. And you declare it as you can see here. You just type down int, all in lowercase letters, short for integer, and then you just write down whatever name you want to have on this variable. And then obviously finish it up with SMI column. Then next we use the stdcin function to read the value from the keyboard. So I just write down std : cin, and now I'm using the arrows pointing towards to the right, and then after the arrows I just put the name of the variable, stating that whatever you have read from the keyboards, put that thing inside this particular variable. Okay, based on this input, let's have another example. Write a program that reads two numbers as integers, calculates the summation of them, and prints the summation of these two numbers. Let me clear this thing out. So I need three variables here. One variable for the first number, a second variable for the second number, and a third variable just to keep the summation. So I just write down int number, let's say a, put the semicolon. So now I have a single variable whose name is number a, who can keep integer values. I'm declaring a second variable called number b, and a third variable called, surprise surprise, summation. Then I use the sin to read the first number. I use the sin again to read the second number. And then I just say that sum equals number a plus number b to calculate the summation of these two numbers, and then putting the result of the summation into the variable whose name is sum. Finally, stdcout, I'm just gonna say the summation of these numbers is sum. Run. Okay, here you see that my program output is a little bit different now. I'm not seeing exit code 0 because the program is not finished yet. Why? Because the program is now waiting for me to give him an input. Why? Because there are stdcins in my program. You can also notice that there's a red button here saying stop lecture 1_1. If I press this button, the program will prematurely finishes out. It can be helpful from time to time, but not this time. So I'm just giving two numbers, 6 and let's say 14. And I press enter. And he just says the summation of these two numbers is 20. Now I see that process finished with exit code 0 because the process really did finish without any errors. So let's look at the code one more time. I have three variables for different purposes. I have the number a, a variable whose type is integer, whose name is number capital A. Similarly, I have a second variable to keep the second number, number b, and a third variable just to keep the summations value, the summation of these two numbers. These are variable declarations. I am just basically reserving three blank pieces of paper just to keep three different numbers onto. Then I read something from the keyboard and I put that something into the variable whose name is number a. Next, I read another thing from the keyboard and put that thing inside the variable whose name is number b. Now, in our two out of the three papers, there are some numbers, right? One number in the first page whose name is number a, another number on the second page whose name is number b. Then I just say sum equals number a plus number b. I just read the numbers written on these pieces of paper, added them up, summed them up in my mind, because I'm not that terrible of a person. I don't instantly forget that. And just before I forget that value in my mind, I just hastily write it down on the third page whose name is sum. So I just say sum equals number a plus number b. Finally, I just give the output to the screen, to the console, by using the std code. And first I'm gonna say a static thing saying the summation of these numbers is blank. Follow it by the name of the variable I want the value of to be written. So the result is kept inside this variable, sum. So I just say, okay, add after this sentence, just add the value kept inside the variable whose name is sum. Finally, put an end line here to show that, okay, go to the next line. So that is how you read two integer numbers from the keyboard, calculate the summation of them, and then print out the summation of these two numbers. One more example, a little bit of an extension of the previous one. Write a program that reads two numbers as integers. Okay, we did that. Calculates and prints summation. All right, we already did that too. Also subtraction, multiplication, division, and mod of these numbers. Okay, so 4 more operations, and these operations also require different variables. Okay, I go to my code. Now I'm gonna declare multiple variables here. Int subt to keep the subtraction, let's say. Int, let's say mult for multiplication. Int div, and int mod to keep the mod operator's value. So first we just said sum equals number a plus number b, and then the summation is like this. Then I go here and say subt equals number a minus number b. As you can see, C-line is helping me, and he's just telling me what possible variable names that are with a little bit of a menu here. So I just choose whatever numbers are available, whatever variables are available for me to use, following the letters N, U, M. So these things are gonna make your life much easier if you are starting to write down very, very long codes. That's why IDEs make life as a programmer very easy compared to simple things like the Notepad or the WordPad. But if you are a C++ guru, you may say like, I don't need these things, I can do them in my mind. And yes, that is a good approach, but for the first time beginners, I strongly suggest an IDE because of these additional helps they can provide. Okay, I'm copying and pasting this part now. Maybe I have to delete these lines. The subtraction of these numbers is subt. Then mult equals number a times, using the star symbol, number b, multiplication of these numbers is mult. Let me copy and paste these things two more times. The first one is called a div, and then I'm gonna use a slash just to represent the division operation. The division of these operators, division of these numbers is div, and finally the mod, which you are gonna be using the percent symbol to represent. The mod of these numbers is, well, mod. Let's run. Okay, I'm giving the two numbers, let's say again 6 and let's say 9. Summation of these two numbers is 15, alright. Subtraction is -3 because I subtracted, like I just did 6 minus 9. Multiplication is 54, division is 0. Okay, that looks a little bit strange. 6 divided by 9 is not 0. It should be like 0.666. Am I right? There's something weird going on there. What about the mod? The mod of these numbers is 6. Okay, that is fine because 6 mod 9 is fine. The only potential problematic thing here is this division thing. This is something that I will be calling an integer division because I am only using integer numbers here instead of the real numbers. When you just divide an integer number by another integer number, and the result should be an integer number, and there are no multiples of 9 inside 6, therefore the division looks like a bit of a weird thing. When we go to doubles, a different type of variable which can keep real numbers, you will see how we can make another real division. So for the time being, let's keep that thing as it is, and then we will see about how to fix this thing if we need to fix this thing in the upcoming parts. Speaking of the variables in more detail, let's look at the common variable types that are available for us in C++. Super roughly, C++ divides the variables into two very broad categories: the fundamental data types and the classes. Fundamental data types are simple constructs that can hold a single value of a given type, such as an integer, a double that can keep a real number, a character that can keep a character, and so on and so forth. Classes, on the other hand, are able to keep much more sophisticated structures. They can keep multiple integers together, arrays of integers, very different things, some conceptual things like a car, you can say a monitor, a glass, things like that, but which will be based on the fundamental data types or other classes, but they are a little bit more sophisticated. We'll be looking at the classes at the end of this video series and in the subsequent video series on the CMP 1002, the object-oriented programming. For most of this video series, we'll be focusing on the fundamental data types. So, for fundamental variable types, the first one is the one that we have already been introduced, the integer, short for int. You know how to declare an int using I and t, all in lowercase letters, and then you can just put whatever positive, negative, or integer value, or 0, inside an integer variable, as you can see here, and you can just get the input using the stdcin. But the thing is, integers or any other variable types have a size in any programming language. And C++ in particular have roughly 4 different versions, 4 different variants of the integer. Each one of them have different sizes. So if you are trying to keep a very, very long number, let's say 1 trillion, inside an integer variable, you see that the integer will not be able to hold that much of an information because it is just not big enough for the integer size. If you use, on the other hand, a long int, then you will be able to put a 1 trillion value inside a variable. So these 4 variants of int are int, short int, long int, and long int, which, if I'm not mistaken, has been added in C++ 11, but I might be mistaken. Unfortunately, there are no fixed sizes in C++ for these types of variables. Instead, there are rules like the integer must be at least 16 bits long, but it can be 32, it can be 64, depending on your operating system, your computer's hardware, and even the compiler that you are using. Short int, same, at least 16. Long int is at least 32 bits, so it is gonna be by default bigger than an integer. And long int is gonna be at least 64 bits long. Be careful, the int and short int looks like they have the same sizes, but in other systems, for example, in a regular 64-bit system, if I'm not mistaken, int will have a size of 32 bits, whereas the short int will still have a size of 16 bits. And based on the number of bits that are being used, as you can see, the value ranges change from -2 to the power that bit -1, so -2 to the power 15 to 2 to the power 15 -1 if the variable is using 16 bits. The second important variable type is the double. Double is, in contrast to the integer, is used to store real numbers, such as 1.54, 6.783, and so on and so forth. We use double for declaring double variables, again all with lowercase letters. Double is generally short for double precision floating point number. It's a bit of a longer name, and well, you need to check some other references that I will be putting in the links about what is the meaning of a floating point. It's basically like this, the decimal point of the number is moving around, floating, flying around. And there are a bit of a standardization effort has been done over a couple of decades ago. It's been written under IEEE 754, if I'm not wrong, the floating point standard. And if I'm not mistaken, all common languages today are using the same standard. Nothing is changed for reading things to a double variable. Same rules apply. You can use the same stdcin. Similar to the integer variants, there are three variants of the double: float, double, and long double. So float is the floating point, and double is double precision floating point. Again, instead of the integer, there are fixed sizes regarding this float, double, and long double, as you can see here. And the value ranges again is a bit longer, but they might seem a bit daunting and very weird, like not 2 to the powers, but e to the power somethings. Again, if you want to go to the details about why it is like this, please do read IEEE 754 floating point standard for the details. Let's go to this example, which says write a program that reads two real numbers as doubles, calculates summation of them, and then prints the sum. Okay, I don't want to forget these commands, so I am just gonna select all of these codes and just comment them out. So I just put two backslashes in front of every single one of them. This means that these codes are now out of the code, basically. So the compiler will completely disregard these lines. These lines act as if they don't exist for the compiler. So they will not go inside the program. They will be disregarded. But from a human point of view, we can see that, so we can reuse them. So I'm going to say double number A, double number B, and double sum for summation. Again, sin, I'm reading the first number, I'm reading the second number, and then I'm gonna say sum equals number A plus number B. And finally, the same thing is going on. Voila. So let me give the numbers 4.56 and 7. Let's say 091. And the summation is 11.651. Note that the decimal point can be different in different languages, such as in Turkish, instead of the decimal point, the comma is used because the meaning of dot and comma in mathematical notation is reversed in Turkish and English. So since this machine is on an English operating system, it is following the English language rules. The third important basic data type is Boolean. Boolean is a much simpler data structure. It is used to store a true-false value. We just write down BOOL, again all in lowercase letters, and you can just keep, as I mentioned, a 0 value or 1. So you can either write down a number inside, or you can just write down true or false here. If you just write down true, he will immediately convert it into a value of 1. If you write it down as false, then he will immediately convert it into the value of 0. The bizarre thing regarding the Boolean is the fact that if you write down 0, then as a numerical value, it will become false. That's good. But if you write down any other number, it could be a positive number, it could be any negative number, then it's gonna be true. So if I say, as you can see here, flag equals -5, then it's gonna be considered as true, which might be a bit confusing, but since the logic goes like this. 0 is there any value or not, kind of a concept. 0 is okay, I know that 0 is also have a value, but it is something like that. So -5 is something, therefore it is true, something like that. Boolean is generally used to keep some special types, some special uses like a flag, which I will be using in the subsequent videos in some other examples. The fourth very important type is char. It is used to store a single character. It could be a letter, an uppercase letter, a lowercase letter, a single digit. So you can keep like 5, 0, 2, but you cannot keep 14, 15, because 14, 15 are composed of 2 characters. Be careful. 14, 1, 4. You can also keep exclamation marks, commas, even blanks there, any characters that you can see. So when you are declaring, you just write down char, all again in lowercase letters. And if you are trying to put a value inside these variables, you have to put them within single quotes, as you can see here. Char blank ch equals within single quotes capital A. Reading something to a character is no different than reading an integer number or a double number. Each character value in C++ is a corresponding ASCII or Unicode value. So you can imagine that as a numerical representation of the character for the computer. So the ASCII code of capital A, but be careful, capital A is 65. So the code of capital A is 65 for the computer. So the thing is, the computer doesn't know what capital A is. So he can only store bit values. If the bit value or the value of the bits representing a single character is 65, he understands that this is the letter capital A. So as such, you can keep the character as a character, or you can also keep the ASCII code of a character, which will give you a bit of a flexibility when you are dealing with characters, and is it like the 5th character, 10th character of the alphabet, things like that. The example says, write a program that reads a character variable, prints the character, and is ASCII code on the console. Okay, let me go to C line. So first of all, I'm commenting out all the old codes. I don't want to forget them. So char, ch, I'm declaring a variable whose name is ch, whose type is char. And then I'm gonna declare another variable whose type is integer, and then I'm gonna call it the ASCII value. I will be calling the cin and then putting the red input inside the character variable. Then I'm gonna say ASCII value equals ch. The important thing here is ch is a character, so it will hold a character value. And now I'm trying to put that character value inside the integer. So the C++ in this context just gets the ASCII value of that character, whatever that character is, and puts it inside the variable whose name is ASCII value. Then I'm gonna say std quote, the character that is read from the keyboard is ch, and similarly the ASCII value of the character is ASCII value. So let me give him capital C. So the character that is read from the keyboard is capital C, and the ASCII value of the character is 67. Note that I'm always referring to only capital C, not just C, because let me give him lowercase c. As you can see here, the ASCII value of the character is 99. So the ASCII values of lowercase letters and uppercase letters are different in ASCII, because otherwise the computer has no means of differentiating between a lowercase letter or an uppercase letter. The ASCII values should be different. The final type of variable is the string. String is basically a big brother of the character, so it is like it is used to store multiple character values. So declaration, we use std : string for declaring string variables. And you can again use the CIN to get a word from the keyboard. But be careful. The std CIN can only take an input until he finds the first whitespace character. And whitespace characters are blank, tab, and enter. So by using the std : CIN, you are only limited to getting a single word out of the user, not a sentence. As you might be seeing from the differences between the name of the std string compared to char, int, double, float, these kind of things, it is not a fundamental data type. It is actually a class. But I can say like string is a very, very core class. Instead of getting words, you can also get a sentence until the enter character has been entered. For this purpose, you have to use the getLine function. And how do you use the getLine function is a little bit different from the std CIN or the std codes that we have been using in this video. So you just write down getLine and open it up a regular parentheses, put down first of all the std : CIN, put a comma, and afterwards put the variable which you want to keep the input into. This is actually a function use which we'll be seeing in the next couple of videos. So the example says, write a program that reads a string variable as a line and prints it to the screen. Okay, std string, let me call it s, and then I'm gonna say get line std CIN, comma, s. So these ampersands are automatically added by the CLine. They are not actually part of the code. They are just helping us to understand what type of the variables that I am passing to this getLine function, which we'll be covering in the video regarding the functions. So std cout, the input read from the keyboard is s, std, and line. So I'm just gonna give an example sentence: welcome to the CMP 1001. So now you can see that I'm getting the whole sentence. But since I forgot to put a blank between is and the welcome, you're seeing that they have composed a single word. Let's look at, instead of this getLine, if we only use the std CIN, what's gonna happen? And we give him the same input. So std CIN, and then I write it like this. Here I'm giving the same input, welcome to the CMP 1001. And as you can see here, he's only getting the welcome with the capital W. Because as I mentioned, CIN only gets input until he finds the first whitespace character. And in this scenario, the first whitespace character is the blank between welcome and to. Therefore, he only reads the input until this blank. So the input becomes only welcome. Alright, so today we have made an introduction to the programming concept in general, and then we give a look to the C++, different versions of the C++, where to write our program, how to compile and how to build our program using GCC or a Windows port of GCC, and we have introduced how to get input from the keyboard and how to write down output to the console or screen if you want to say. Then we looked at the fundamental data types in C++, such as the very well known integer, the double, boolean, character, and the not so fundamental data type but nearly fundamental data type I can call the class string. In the next video, we will be continuing with the variables in more detail, and we will be looking at the basic operators such as the assignment operator, the mathematical operators, and the increment-decrement operators. Thank you for listening, and let's see you in the next video.